Well, I am super excited to have my biohacking bestie, Leslie Kenny, on the podcast again today. And she is amazing. I always love learning from her. And today we're going to talk about the 9 hallmarks of aging. And you probably never heard of these before, but they're a pretty big deal in the world of aging and gerontology. And they explain why we are aging. And Leslie's going to help us biohack our way to put these hallmarks in our favor. So to give you a little background on Leslie, she is a native of Southern California, like me, living in Oxford, and she is a certified health coach with the Institute for Integrative Nutrition. She was in the first cohort of Dave Asprey's Bulletproof training, so she is an early adopter in the biohacking community, and she's a great patient advocate, and she's graduated from Harvard and Berkeley, so she's a little smarty pants here, and she became a sexologist, and now she's the founder of Oxford HealthSpan, which is a nutraceutical company promoting a healthier, longer life for everyone. And Oxford HealthSpan is also the maker of my all-time favorite supplement, as you guys all know, Primidine, Spermidine. And so you can see Leslie is a pretty multi-talented and busy person. And in fact, she travels the world speaking at international conferences on aging. And she recently shared her knowledge at the Biohacking Summit in Finland last month. And now she's going to share it with us. So without further ado, meet Leslie Kenny. Welcome, Leslie.
Hey, everybody. It's so good to see you. And Zora, always lovely to be here with you and to chat with you, whether it's on WhatsApp or for a podcast. Love it.
I really recommend everybody to go listen to our other podcasts that we've done on hacking your gray hair, talking about spermidine, talking about so many other great things. We kind of covered some pretty important ones. So I'm excited for this one because you've just really gone deep into the 9 hallmarks of aging. And we did study this in gerontology in my coursework. So, is quite important in that world. And I'd love for you to share what are these 9 hallmarks of aging and why are they important to know?
Yes. Well, so the 9 hallmarks of aging come from a paper by Lopez et al. That was published back in 2013. And it basically created a framework so that we could all understand the 9 pathways down which we age. And there's a lot of debate about how many hallmarks there exactly are. If you talk to our friend, Dr. Sandra Kaufman, who's created the Kaufman protocol, she will say that there are only 7 of these hallmarks. Some people say there are as many as 14. And I'll talk a little bit about some of those additional hallmarks later, but for the purposes of this, I just thought I would start by going through this classic paper. It was based on an earlier paper on the hallmarks of cancer. And let's just jump straight into it. So the first hallmark.
Leslie, I want to just share it with a little bit with people who are listening. We do have Leslie's got this great presentation. I don't know, Leslie, if you could put it big, it would be great if you can see it large.
Good point. Yeah.
And so if you're listening to the podcast, we'll explain a bit what the visuals are when necessary. Otherwise, when you get a chance, go to the Hack My Age YouTube account and you can see the full video presentation. Thank you.
So the first hallmark is DNA damage. And I think that we all know that it's important that we have DNA that maintains its integrity so that we can continually photocopy our cells, that everything looks as it should. But when there is DNA damage, wrong messages are sent on how to replicate things. So that is the first. And the next one is telomere attrition. And that's where our telomeres, the end caps of our chromosomes actually begin to fray. And this is, to do with that photocopying of the cells. There's something called the Hayflick limit, which is the number of times that our cells can replicate properly. And animals like tortoises that live to 130 have very, very long telomeres. And humans have relatively shorter telomeres, they can only replicate, say, 50 times. And the longer that your telomeres are, the more, the more often you'll be able to make copies of these cells.
So it's important that we protect our telomeres so that it protects the DNA, right? So it doesn't get damaged.
Exactly. And this all goes hand in hand. What you'll see with all of these hallmarks is, in fact, there's a lot of spillover. And indeed, there is crosstalk between the hallmarks. So we've talked about DNA damage and telomere erosion, and those have to do with each other, as well as to do with epigenetic changes. So how does the genome actually get changed by things like pollution, whether that is air pollution, whether that's smoking, alcohol? All of these things turn things on and off in our genome in ways that can either benefit us if we're exercising or eating right, or turn them on in ways that are not beneficial to us.
So those are epigenetic changes.
Yes. Then impaired proteostasis is the fourth hallmark of aging. And this is where you need to have proteins folded inside the cell. So the hallmarks of aging have a lot to do with cellular functioning. And inside the cell, you have your mitochondria, and you have, these proteins that need to be properly folded to fit together to function correctly. And if they are misfolded, as you can see in this particular image, they're not going to function properly.
So the mitochondria are the powerhouses of our cells. If you remember that in biology, that's what gives us energy, but also the body energy to function and work optimally.
Exactly. So, and that is indeed the next hallmark, which is mitochondrial dysfunction. So if you have impaired protein folding inside the mitochondria, you're not going to get the same kind of energy output that you would otherwise.
So it's kind of like actually what you just described. This is what, number 6 or 5?
This is 5, yeah.
And so, when we talked about, you mentioned first, the DNA damage and the telomere attrition. So yeah, if your telomeres are eroded faster and you're shorter, then your DNA is more damaged. And if your DNA is more damaged, or the cell itself, is not functioning optimally, then we have the mitochondria there. And it's just seems like there's this flow even where, it's like you said, crossover. So it's you can see how this can be, the chain, the link is actually formed.
Exactly. They're all linked to each other. Altered nutrient sensing. Sorry about the quality of this particular slide. These are neurons that are trying to sense nutrients. And one of the things that we know about patients with Alzheimer's is that their neurons are no longer able to sense things like glucose properly. Sometimes those receptors for glucose are actually covered with a biofilm. And this is why finding an alternative energy source like ketones, because ketones always work. They work from the time we're in utero to the time we're infants and are being breastfed, to the time that we die. Ketones work as an alternative fuel source. Then there's stem cell dysfunction, which I don't think I need to explain. I think all of us know what that is. Impaired intercellular communication. Again, the ability of cells to communicate with each other, very important. And finally, the 9th hallmark is cell senescence. And this is where, as we get older, some of those cells, once they get to that Hayflick limit, they should die in a process called apoptosis, but they don't always die. And they can linger in the way that zombies can, right? And if anybody's ever seen one of these zombie horror flicks, what happens is that a zombie comes to town and then infects one other person and then another person. And it's sort of that cascade where suddenly the entire neighborhood is infected. And that's the problem with these zombie cells. They sort of hang around. They don't actually contribute to the health of that community of cells. And in fact, they detract from the performance of that entire group of cells. So getting rid of those cells so that they don't have that, that negative impact is then quite important.
Can I ask you a question?
Yeah.
So what is the difference between the nutrient sensing and the intracellular communication? Because they sound quite similar.
Yeah. So nutrient sensing is about energy, but sending messages between cells is different. So that's really the difference there. One is taking food in. The other one is really about sending something out.
Got it.
But what's interesting, I mentioned that there are papers that in fact say that there are more than 9 hallmarks. And I saw one, I think somewhere, that said there were 14, and I can't remember all of them. I remember that they, because they're at this point in time, there's so much debate around this. But what does seem to be consistent across all of the new papers is that impaired autophagy is itself a hallmark of aging. And what I'd like to do is just talk a little bit more about autophagy itself. So we know that it comes from the Greek, auto, self, and phagy for eating. And it's really this the cellular housekeeping system. And I was talking to someone who said that they'd done a very good job when they were young at keeping their home pristine. And then when their children came along, they started gathering lots of pairs of shoes, Lego, too many plastic toys, lots of clothing for the children as they outgrew them, but then didn't get rid of them. And that's sort of what happens to us, to our cells as we get older. We sort of gather this cellular junk that sort of has a drag effect on us, right? So if we think about autophagy as having our own personal Marie Kondo in the cells, saying, yeah, those shoes, that's got to go to recycling, right? The Lego, let's definitely get rid of that, give that to somebody else. And just looking for the things in the cell that spark joy and work well and getting rid of everything else, that's what autophagy is. And there is, in fact, a reason why I like to bring Marie Kondo into the conversation, and it's because the mechanism of action of autophagy was discovered by a Japanese scientist named Yoshinori Osumi, who won the Nobel Prize in medicine or physiology in 2016. And one of his lab assistants, who is now a professor at Osaka University, Tomatsu Yoshimori, is the world's leading expert in mammalian autophagy and how that process works, because there are very interesting mammals like the naked mole rat that are very capable of maintaining autophagy for a long time. And I don't know if I need to go into how exactly autophagy works, because I've mentioned how it's kind of a bagging up process. You've got these trash bags that engulf all of this worn out cellular material, misfolded proteins, damaged mitochondria, and then it connects to something called a lysosome. And anybody who's watching this will see a little red or orange dot. That's the lysosome. And you sort of need the same number of lysosomes as you do those bags so that you can actually burn up the bag. And the burning up process is what gives people energy. When you fast and your body says, right, I have no food coming in, I need to burn something for energy, it actually kickstarts this autophagic process, because you can create energy by having autophagy in the body.
How is autophagy different than mitophagy? I've heard of mitophagy before.
Mitophagy is it's a related process, and it's basically where you take the mitochondria and you do the same thing. So there is this bagging up of the mitochondria, and it is actually the damaged mitochondria are sequestered and they are replaced.
Do you know if that happen in conjunction with autophagy?
It does, yes.
Mm.
Yes, exactly. And virophagy happens at the same time, as does lipophagy.
Mm.
There are quite a few of these ophagies. There's something called ferritinophagy, which is where ferritin releases iron. And individuals who have had COVID and did not, because the virus needs iron to grow, a lot of these folks seem to have very high ferritin levels afterwards. And in fact, the body was stopping the ferritinophagy, the autophagy process, so that the virus could not grow with the release of iron.
Wow.
So I guess one of my big takeaways from talking about all of these hallmarks of aging is that there's a lot of crosstalk between the hallmarks, as we saw with telomere attrition, DNA damage, epigenetic changes, for instance, and that autophagy itself is a hallmark, but that it can, in fact, improve a number of these hallmarks. So we know that that autophagy helps with things like DNA, preventing DNA damage, and preventing stem cell exhaustion. And so this statement, which is on the screen here, which is dysregulated autophagy is a cause and not a consequence of aging, is a really important one to take away, because it says that when we get older because autophagy is dysregulated. It's not that as we get older, autophagy must be dysregulated. It's not that aging causes this dysregulation. It's the other way around. It's dysregulated autophagy that starts this aging process. So if we can keep autophagy functioning perfectly, we can slow down, maybe reverse, but at least slow down the pace at which we age. And that's why you can take two twins, one who say smoked and one who hasn't, and you can really see the difference in aging between the two, because the smoker will have dysregulated autophagy, right? Mm. So what is interesting also is that if there is just one mutation in just a single part of the autophagic machinery, that is enough to cause significant implications for health span. And that just goes to the heart of how important it is to make sure that everything within the autophagic machinery is running properly. So this particular slide really looks at the impact of autophagy on all the hallmarks of aging. And I sort of wanted to show that, that autophagy can positively impact all of these hallmarks. And although it may be a hallmark in itself, all of the 9 can be impacted. And we have evidence that we have scientific proof that it definitely inhibits 6 of these hallmarks. So again, things like telomere attrition, epigenetic changes, stem cell exhaustion, misfolded protein, those types of things. And because of the fact that there is crosstalk amongst them, the more hallmarks we can inhibit, the greater chance our bodies have to inhibit the remaining 3 hallmarks that we have not yet scientifically proven autophagy impacts. I would posit, though I have, we don't have the scientific proof, but I would posit that autophagy has an impact on all 9. For instance, with regard to cell senescence, we don't have proof that completely, ironclad proof that autophagy that it will inhibit cell senescence, but we know that it does this with the immune system. And so if it does it with one system in the body, I think it is at least possible it could do it with other parts of the body as well.
So can I ask another question then?
Yeah.
You would think that autophagy would be like the 10th hallmark of aging, at least, because it's so important and it is so integrated into the other 9.
Yeah.
You said that there are some people who say there are 14 hallmarks of aging. Is autophagy one of them?
Yes, autophagy is definitely one of them. Yes.
Okay. So it's just a matter of time before the rest of the scientific community accepts autophagy.
Well, yeah, I think it's different definitions, right? And the more we learn about the importance of autophagy to cell health, health span, and survival, the more clear it becomes to me, and I think to others, that this is a really big lever that we can use to slow down the aging process, prolong not just life, but healthy life, right? Because nobody wants to live long if they're sick. So that was really the potted answer to what are the hallmarks of aging. I just thought I'd use those slides because they help go through and really show what what they are.
Yeah, the visual.
Feel free to ask. Yeah, the visual part is kind of helpful.
The visuals part is important. So, and anyone who's listening and learning about the 9 hallmarks of aging for the first time, you're going to forget it. Don't worry. You need to repeat this like 100 times until it just kind of sinks in. So don't worry if it just kind of goes over your head a little bit. The big picture is that there are these hallmarks of aging. They exist and they are impacted by autophagy. You probably have been listening to the podcast. You learned a lot about autophagy already, but if it's your first time, no big deal. You're going to hear it a lot more now that you've heard it. And so it actually, one of my questions was, what is the most important hallmark of aging? And I'd almost answer that with autophagy, even though it's not technically that's actually my answer. And I knew you were going to ask that question, and that's why I particularly wanted to show, to go through the first part of that deck, was really just to show how important autophagy is, but also to really impress upon people that there are a lot of these hallmarks, a lot of crosstalk between them. If you can hit just one of them, you will positively. Autophagy can actually inhibit 6, which, if hitting just one is a good thing. For example, NAD, I think, hits. Just quickly take a look here at my slide, but NAD enhancers hit impaired intracellular communication. That's one. NAD is nicotinamide adenoside something. What is it? How do you?
Yeah, I think I really just know nicotinamide riboside.
Yeah, nicotinamide riboside. And then there's the NAD. So NAD, if you've heard us, that probably you heard before, and that's very, very important for energy and just for overall health and longevity. We've had this discussion with Dr. Nina Lauk. And so you want to have NAD. That's a good thing. We want NAD. And very often people take NAD precursors or like NR or NMN or even Nichito. And that's where they try to get their NAD boosted, because we lose it as we age. That's why little kids are spinning around like crazy, because they got tons of it. I just want to explain a little bit what NAD is for some people who don't know what that is. Sorry.
Yeah. So one of my favorite charts is the one that Professor Linda Partridge, Matthias Fuente Alba from University College London, and Brian Kennedy at National University of Singapore did a couple of years ago. And this was published in Nature Reviews Drug Discovery. in in a paper called The Quest to Slow Aging Through Drug Discovery. And they rank all of the targets to slow aging against the 9 hallmarks of aging. And when I saw this and I saw NAD and it said 1, I thought, but I don't understand, because I hear a lot about NAD and how important it is. And certainly when I take nicotinamide riboside, I do feel it. When I take, say, Nuchido, I do feel it. And so then I'm thinking, but wait a second, molecules that actually trigger autophagy, like spermidine, which is listed on this chart as well, actually inhibit 6 of these hallmarks. So
Amazing.
why are we not jumping up and down about that? Right?
Yeah. Why is everybody so excited about NAD when it's just hitting 1?
Well, if that's,
hallmarks.
Yeah, and clearly science does march on. This paper was published, I think, in 2020. And certainly since the time of publication, another hallmark that, say, spermidine inhibits has been found, which is telomere attrition. But, I'm sort of thinking, okay, so what are the other things that NAD is hitting here? But we can do a protocol where we try to hit all 9 hallmarks of aging with a smart stack, right? And part of that smart stack can either be geroprotectors like spermidine, NAD. Some people use metformin, some people like lithium, some people like rapamycin. That's not my favorite. That's not Sandy Kaufman's favorite. We really don't like what it does to hippocampal volume. But you could mix and match things to inhibit all 9 of those hallmarks. And there are lifestyle factors that we can take advantage of that also will trigger autophagy and hit many of those hallmarks of aging. So sleep, when we sleep, the body has a chance to, to fast and then actually repair the body. Saunas, heat shock proteins, which we talked about at the very beginning of this interview, that helps. Cold shock proteins will also help. Exercise helps as well. And so just mixing and matching between the lifestyle interventions and these molecules that help inhibit the hallmarks gives us a fighting chance of slowing every single one of those hallmarks so that we slow our overall pace of aging.
So then let's get a little specific then. And, because it really, to me, if autophagy is hitting all those 9 hallmarks of aging, I'd just go straight for the autophagy. Like, that's probably quite easy. But it appears to be the case. It's, in terms of say, cell senescence, we need to definitively prove that. Okay. Well, we can still do other things then for the senescence. And so, you say exercise, for example, can trigger autophagy, or sauna or ice bathing. So, what kind of exercise, how much time, and does it matter if you're a 50-year-old woman or an 80-year-old man? Is that a different formula?
It does. It is a different formula. And frankly, it's going to be different for every single one of us. So let's just talk about lifting heavy weights versus walking. Muscle is protective. We know that healthy centenarians maintain muscle. And that's important for things like balance. It's important for simple movement. But muscle also emits myokines, which are anti-inflammatories. And some of those other papers that talk about the additional hallmarks of aging actually say inflammation is a hallmark of aging too. So it would, if I had to choose between walking, very good to get circulation going, blood pumping, some use of muscles, very good. But I think the heavy weights is a good thing to develop muscles, or trying to hack that by using things like blood flow moderation bands or blood flow restriction bands. That might be a way to build muscle faster. If you weren't able to access heavy weights or lift them due to injury, for instance, and the Japanese do use blood flow moderation bands, KATSU bands, with their rehab programs, with their open heart surgery patients, with their centenarians. There's some great footage on YouTube of, I think, a 104-year-old woman who used them for 6 months and, you know, grew more muscle even at that older age, and was able to hold herself upright, walk with a greater, with a faster pace and with greater confidence. So I tend to like muscle, but you actually have probably more knowledge on the exercise front than I do, given your background and as an athlete. So I really should be deferring to you.
Yeah, no, I'm a big fan of keeping our muscle. There's so great, wonderful things. BDNF, we're talking about aging, brain-derived neurotrophic factor is released, and this is wonderful for the brain. The blood flow. You can get this with the blood flow restriction as well, the KATSU bands, and I've been talking a lot about it lately on my Instagram and Facebook because I just love that. But exercise it's hormone balancing. It's everything. And I think you're absolutely right when it's, that question I asked you, how much and everything, it's really bio individual. And so, for you and me, or we're pretty fit and we can do a HIIT training, or, just getting our heart rate up, to 80% more or less of our maximum heart rate is where we kind of want to be a little, for a while, but not too much, right? Especially when we're going through menopause. So we don't, exercise is increasing your cortisol. And usually by the time we get to our age, we got enough of it. So we need to find the right amount. But when you get an 80-year-old woman who's just starting out with exercise, she couldn't possibly do the same things you and I are doing if she's never, had a training program. So, but then, you look at people like Train with Joan, who can lift a lot more weight than me, and she's 75. So again, it's so individual, but I think it negates, exercise to me negates a lot of the negative effects of so many things that are happening in our lifestyle and our diet. And you can't out exercise a bad diet, that's for sure. But you certainly can do a lot, reverse a lot of damage in general in the body with the appropriate amount of exercise. So again, to answer my own question, it depends.
Yeah. And listen to your body, right? We know when we've done too much. Or if you've got a device, a wearable tracking device, like an Oura Ring, look at your resilience, your readiness, and listen to what that's saying, because sometimes it does know better than we do when we are very inclined, say, after recovering from COVID, to go out there and hit the gym hard. It might not be a good idea. And sometimes these tracking devices can give us that feedback.
Oh, I love them. Yeah. So, okay. We got the hallmarks of aging and we got into the science and understand that. Now, we didn't talk about, but I think it's just kind of assumed that when you have damage to these hallmarks of aging, or when these hallmarks of aging are going in the wrong direction, then it sets you up for diseases of aging. So you're just more at risk. And so that's just kind of to say, talking about cancer and diabetes and our heart disease, our Alzheimer's, all these things you could link to the hallmarks of aging. And that's why we talk about it. So, age is the biggest risk factor for all diseases. So just a fact that
biological age.
Yeah. Exactly. Yeah. Chronological age is the number of years on, number of candles on your birthday cake, but your biological age is how old you are really on the inside. And you're absolutely right. That, and you can see that with 50, 60-year-olds who look younger than they do, and some that look much older. So, this is why we're talking about the hallmarks of aging, because we're an audience here of women over 50, and we're concerned. We see maybe your own parents dealing with dementia or Alzheimer's or Parkinson's, and then we think, oh my goodness, is this going to happen to me? Because we say, oh, this is in our genes. But we know now that genes are the loaded gun, and lifestyle is the trigger, right? So it's only about 10-20% of the risk of diseases, and we can control a lot through the epigenetics. They're 80% more or less. I mean, everybody has a little bit different number, but when we talking about those diseases, what's very interesting is that women are living longer than men, but we have more diseases, right? So we want to take a look, how can we slow down, lower our risk for these diseases? And, also the question is, why do you think this is happening? We live longer, but get more diseases.
Well, there are a couple of reasons. I think that women do have estrogen, and that is very protective. There's evidence that exposure to testosterone, while it does help men with their muscles, that can actually predispose them to a slightly earlier death. And I think generally men live about 5% less or fewer years than women do. But men tend to die with fewer years of ill health than women. And that is the bit that I would like to see change. And where I think that things like optimizing our hormones, whether it is estrogen or thyroid, can make a big impact, but also by triggering autophagy and making sure that it's functional autophagy, not dysfunctional autophagy, right? Mm-hmm. Really could help. And yet most people, when they think of autophagy, they think, well, I'll go into ketosis and I'm going to fast, and then I'll be able to trigger autophagy. And that works if you have a lot of weight to drop. But if you're an older woman and you're already slender, if I've gone to some of these spas and said, oh, I think I should lose some weight. And they'll be like, no, you don't want to lose weight, because look at how skinny your wrists are. And, they do their checks of BMI and they say, no, actually you shouldn't try to lose weight. Fasting is then not a good thing for these women. And you want to look for other lifestyle interventions or geroprotectors to use to trigger the autophagy in you. And for example, spermidine might do it. Nobiletin, which is another molecule that triggers autophagy, and that is found in citrus peel, that could do it. And it's not going to cause you to lose your muscle or your weight if you are one of these very slender older women. So bioindividuality, again, is the name of the game here. And we want to make sure we come up with a protocol that's right for each person so that they can find exactly the right program to trigger autophagy, hit those hallmarks of aging, as many as possible, slow them down, so that they can then avoid the aches and pains of aging or the diseases of aging.
Yeah, I think, me, I'm a Dr. Stacy Sims fan, and I've gone through their program, the menopause for athletes. And what she's showing us is fasting and keto is not good for women, not young, not old, but particularly if you are athletic. And athletic doesn't mean you're an athlete. It means just that you have planned exercise. You're going to a gym, or you're going outdoors and doing something. And this is not good for our hormones. And, there are some successes. And again, fasting is such a broad term. And what does that really mean? But, when she's pulling the studies out is more of a longer fast and more often. And when you're training and you exercise, well, then you need to fuel and you need to fuel your training. So those people, if you want to activate autophagy, well, exercise is going to probably do it. You don't need to add fasting on top of it because it's just too much of a stress.
It's a huge stress, right? All that cortisol. Yeah.
Yeah. Exercise is a stress. Fasting is a stress. Everything is these little stress, but stress is not bad. We just don't want to, pile it all on top of each other altogether. There's appropriate times and appropriate ways to do this. But there is a great question here in the chat where we're talking about autophagy. Is there such a thing as too much autophagy?
Oh yeah. Just like there's a thing, too much fasting, right? You don't want to fast 365 days of the year. Equally, you don't want too much autophagy because you'll kill off healthy cells, right? And so you don't want to use chemical interventions because, well, in most cases with chemical, say synthetic spermidine, we have no idea what the results will be on the human body because we don't have any safety trials on those in humans. If we're getting it from food, happily, the body has an inbuilt system to say too much, can't do more spermidine from, say, natto or mushrooms or wheat germ, because the body just can't take in that much to the point of toxicity, right? Which is a good thing. But yes, you don't want too much autophagy because you will compromise healthy cells.
So you mean then when we get spermidine, say, from food, it's quite safe because the body just shuts down the autophagy process once it's kind of done.
Actually, it's more that our bodies say, I can't eat more, right? And so it limits the amount of those molecules that trigger autophagy in the body. I have met people who've said, oh, David Sinclair said he takes a gram of spermidine every single day. And he misspoke there.
I thought so too. I remember he said that and I was like, I think he meant milligram.
Yeah, he meant a milligram. He meant 1 milligram, not 1 gram. There is only 1,000% difference. But I did have men asking me, well, why would I take only 1 milligram when David Sinclair is taking he's taking 1,000 milligrams, 1 gram. I need to do that too. And they were looking online for as high a dose as possible, which I think even in the synthetic realm, some of the higher doses are probably, 10 milligrams. And I have to take, I'm going to have to take 100 times that or something. And that is not the way to go. Do not try to hack that system. The body has an innate wisdom to both optimize your biology, but also keep it safe, right? I mean, and the same goes for exercise. We have a point of exhaustion where the body simply says, no, I'm not going to do anymore. Just stop, right? And it's there to protect us. It's not there to limit us. I know a lot of people in the biohacking space will say, oh, my body wouldn't let me do more, angry at it. Well, actually, that's a protection.
Yeah.
Right? It doesn't want more reactive oxygen species from all of that exercise. And it's doing our cortisol, it's doing you a service by stopping you from doing more.
Exactly. That's why you say you have to listen to the body. So then, that makes perfect sense. Because so you can limit, your body naturally limits the amount of food that you take, but we're all taking spermidine tablets. And so we can eat a ton of that. And so how much is taking too much spermidine in terms of a supplement form?
Well, the US FDA hasn't ruled on this, but the European Food Safety Agency has, and has set an upper limit of 6 milligrams of supplemental spermidine and food-derived spermidine. And if you look at the diets of the centenarians in the blue zones, they do take in much more. I suppose the question then is, how much are they absorbing? So if we look at, say, an Okinawan diet, they can take in, or an Icarian diet, they can take in 50 milligrams of spermidine through food. But then the question is, are they absorbing all of that? With supplemental food-derived spermidine, we know the absorption rate is actually very high. So you will, if it says 1 milligram, you will most certainly be getting that 1 milligram. It crosses the lumen of the gut very readily. But does it do that with, say, peas? And that's a question that, it's not clear. I would guess that they're not getting the 56 as measured in a chemistry lab, looking at all the food they're taking. I'm guessing that not all of it is absorbed in the gut.
So, I didn't know that actually spermidine in a supplement form is actually, most of it is absorbed. That's incredible, because most supplements we get like 30% absorption rate on average.
Well, it's the certainly with wheat germ, the wheat germ derived spermidine has very good absorption in the lumen, for instance, and that we know the uptake is excellent.
Super interesting. And there's a question here, since we're on the topic of autophagy, what about skin autophagy? Is there anything topical to try?
Okay. Well, you can actually use spermidine in creams topically. And there have been studies showing not only that healthy skin microbes create their own spermidine that is released in the skin biome, but that you can add it to improve wound healing. So there are two separate studies. The second one was on, mixing it in ointments that could be used for psoriasis and would help with skin healing there.
That is super interesting. Okay. Yeah, because in terms of, for me, my first thought was, well, why would we do it topically? Because we get it already. I've seen results. My followers have seen results of just better skin, hair, and nails, and eyelashes and stuff, because just in general, it's happening from the inside out. Yeah. But as you say, there's a microbiome, the skin microbiome, and that's we could pull a Magdalena and just throw it in our masks, then wear it overnight, and she's had some great results, right? And it's a Magdalena secret. Follow her on Instagram, so she's got great ideas. So
she looks amazing, yeah.
But it'd be interesting to see. That, I guess you could try, but there's no studies yet showing that the benefits of putting it on topically yet. Do you know?
No, there are benefits of putting it on topically. That latter study on how it improves wound healing.
Oh, it was a study.
Okay. Yeah, there's a study. I can't remember from which country it comes, but and there's someone else I met said that they'd gone to their doctor in Switzerland, eczema, and that the doctor had said, oh, you should try spermidine cream. I think I have no idea why the dermatologist would have said that there, unless it was readily available. I haven't seen it myself, but I think that at least in the lab, in the university labs, they're working on this and looking at it as something to speed up that wound healing process.
So interesting. Okay, well, I just grated my finger the other day, so I'm going to open up a capsule of spermidine.
Well, you'd have to pack it on with some carrier,
Yeah, what carrier should I use?
Well, I'm thinking, I'm not a skin expert. I'm thinking someone else here would have a better idea of what would be a good carrier. Probably Magdalena would. You'd have to ask her, because I'm not a skin expert. I'm much more a beauty from the inside out type of person. And so I can answer those questions, but I don't feel qualified to answer these dermatology questions, I'm sorry to say.
Well, I'll just do my own biohacking N of 1 experiment and see. Magdalena, do you have any questions, or could you add to that? Do you have an idea what we could use as a carrier?
Hello again.
Hey.
It's interesting because I think that everybody here, about Young Goose, and they introduced ProCare, a new product to the market. It was vitamin C serum, and it was advertised like it's in a way helping to get rid of senescent cells. So that was very interesting. I don't know what to say because, in general, I think that it's very hard that any topical, any cream can help to do something like that, because the molecules should be so small to penetrate, the cell membrane. I'm really always skeptical, we can help with these creams for our skin to look better, that it's smooth and shiny, but I'm not sure that we can help with the products on the market so far to help with such a questions. I think it's just maybe too scientific that one cream can help with such a problems. That's my personal opinion, because I was working in cosmetic industry all of my life, and I can assure you that no cream can solve the problems of skin aging. No cream. Very good skincare can help us that we maintain, let me say, good skin condition, but we cannot get rid of aging. I think so far not possible.
But it's good to support all the other stuff that we do for our skin, right? I mean, using a really not a high quality skincare could actually do more damage to the skin. So I think, there won't be any miracles with this moisturizers and peptides that
there won't
use.
Be any miracles. Yes, that's the best way how to say it. But of course, skincare is very important because we are exposed to UV rays and everything every day, 365 days a year, all of our life. It's the biggest organ, so we have to keep on going to protect it, to take care of it. That's right, but no miracles. Anybody who expects miracles, I think he or she will be disappointed for sure.
Yeah, I think everybody needs to go listen to our podcast that we did, Biohacker Beauty, because you are like in-house biohacking women 50 plus, beauty expert here with a lot of experience. And at 56, you certainly do not look your age. And I encourage people to go find you on Instagram and Magdalena's Secret.
57.
57. Oh my gosh.
We're both the same age.
Yes, very soon. Not yet.
Not yet. Okay.
I'm a winter kid.
Okay.
You are a summer kid.
I'm a summer kid.
Okay. Kid.
Okay. So soon. I knew we were the same age, but yeah.
But incredible. I would like to mention now that I really did try Spermidine. I opened the capsule and mixed it with my night mask cream. And it was really amazing feeling in the morning. I noticed the difference, that the skin was really like, how to say, more nourished than the other night. So I tried this. The only, let me say, negative thing is because we are like mixing some things at home and it's a little bit dirty, if I can say so. Would be great if there can be a product like that on the market to buy. So Leslie, maybe the next, how to say, idea for you to think about this, to launch a product, skincare line with Spermidine. I think this is something we are all waiting for.
I definitely need it. I'm noticing my 11s. So yes, thank you for the inspiration, Magdalena. I will give it some thought.
Yeah, we always were waiting for that. Someone's going to do it. I would love to open the panel to anyone else who's got questions or comments about our discussion here, take advantage of Leslie. She's so knowledgeable. It would be wonderful to hear from you. So anyone can undo their mic right now and just ask away. Don't be shy.
I would maybe point out something what is very important, because more and more Spermidine products are launched on the market. I was already talking to Leslie about it. People are checking just the price. And there are some Spermidine products, supplements, 30 capsules in a box, in a bottle. It's around 30, 35 euros comparing to one of Primidine. And my friends or some followers are contacting me and constantly asking, look, why are you promoting the most expensive product? You see, we found Spermidine, which is once more or less the price, and it's cheaper. So you should buy two, don't promote the most expensive product, and so on. And maybe to tell more, why is that? Why is the price different from some other products? And I think it's very important for people to know this, because some people doesn't know what does it mean to be organic or synthetic and so on. I think this is very important.
So the cheapest products in the market are the ones that are synthetic. So these are perfect two-dimensional chemical mimics of the spermidine molecule. But spermidine in nature does not occur alone. It occurs with the other polyamines, which are called spermine and putrescine. They have horrible names. But those three polyamines work together in what I call a virtuous recycling feedback loop. So if spermine, for instance, is very helpful for DNA methylation, and if the body needs more spermine, it can take that putrescine, which is also in our product, and it can create that. Or if it just needs spermine immediately, it can take it because it is already in our product. So the synthetic products just have spermidine. So they don't have the other two polyamines there. They don't have the recycling and the recycling loop, because all three of those can be recycled into each other. But the other thing is that a two-dimensional molecular mimic is exactly the same as your two hands. And I can take my left hand and my right hand and put them together, and they look exactly the same. It's like looking in a mirror. The problem is, if I said to you, hey, would you like to have two hands, but two left hands? You would look at me as if I was crazy, right? We don't want two left hands. We want one left hand and one right hand. So just because these two mimic each other and they appear to be perfect mimics, that does not make them the same. What our bodies recognize are actually three-dimensional spermidine molecules and not two-dimensional mimics. And I like to think of it as the way you have a glove. So if I take a glove that fits my left hand and I try to put it on my right hand, well, maybe the middle finger fits all right, but the pinky and the thumb are not going to be in the right place, and neither will the ring finger and the pointer finger. It's just not exactly the same. So you're not going to get the same results with a very simplistic two-dimensional mimic. And another thing is that probably the most famous two-dimensional mimic of all time was the thalidomide that was used with pregnant mothers who suffered from nausea during pregnancy. And people said, oh, it's a two-dimensional mimic of what we know works for nausea. Unfortunately, the babies born to those mothers suffered the consequences of taking a two-dimensional mimic that looked like it would be right, but actually inside the body, it did something very different. We do not know what the safety is of these two-dimensional molecular mimics of spermidine. We have done the studies in worms, flies, mice, but normally if you're going to do further, you need something closer to a human. That hasn't been done, and we need trials in humans. Now, with food-derived spermidine, also nobilitin, anything that's been in the food supply for thousands of years we know if it's safe or it's not safe, right? And in the case of food-derived supplemental spermidine, we know very clearly that the European Food Safety Agency has actually examined this and has set their own upper limit of 6 milligrams. And that's a food-derived spermidine. And that's why when I see 10 milligrams of synthetic spermidine, I'm thinking, is that one, is it safe? Two, is it effective? I'm just not sure. And I've never seen other people say things using those types of spermidine saying, oh, my gray hair reversed. And yet we get people who write to us all the time saying, wow, that actually worked. It didn't work 100%, but it's working, right? So the proof is always in the pudding. And that's the very simple answer on the synthetic spermidines. When it comes to other cheaper wheat germ derived spermidines, the issue is then that they don't take out the very fragile polyunsaturated fatty acids that go rancid quickly. So wheat germ is taken out of flour because bakers do not want it in their bread because it limits their shelf life. And as a result, we take it out of our product so that you don't have to deal with any rancidity.
Yeah, I think this is such a great explanation, and people need to really be aware of the differences in the type of spermidine they find. What I like about Primeadine is that that's all you do. You're the experts on the spermidine. Like there's a lot of other supplement companies out there throwing out, who knows, like tons of other supplements. And so I really like that you're focused on this. This is something you take personally, and it's your passion, and this I value tremendously. So if anybody's getting spermidine, I only recommend the Primeadine. That's the only one I know that everyone I know takes and is very happy with. So really, thank you, Leslie, for sharing that. Samantha has a question. I've been taking the non-gluten Primeadine and love it. And I was wondering, what does it do on the brain level? Is there such thing as a brain autophagy? I've noticed a difference since I've been taking it, like experiencing a computer upgrade.
Yeah, so it does. Cognition is one of the human trials that has been done, and we use the minimum effective dose that was used to show improvement in memory and cognition. That's 1 milligram. So we feel confident that we can make that particular claim because the human trials have been done with 1 milligram of spermidine. Now, there is some controversy as to whether or not spermidine can cross the blood-brain barrier. But what we do know is that spermidine has a crosstalk with the clock genes. There are 8 clock genes that we've identified so far, and they speak to the suprachiasmatic nuclei deep in the brain that regulates our circadian rhythms. Any of you who've ever talked to an elderly aunt may know that, that older people have trouble sleeping at night, in particular older women. And one of the reasons is going to be lower progesterone, but the other reason is going to be less spermidine, because spermidine has been shown to talk to at least 2 of those clock genes to help reset the circadian rhythm. Now, why is that important, and what does that have to do with autophagy in the brain? Well, if we sleep better and the first part of our sleep cycle, which is the deep sleep cycle, then the compartments of the brain actually shrink back, and these channels of cerebrospinal fluid actually begin to flow and take out waste. And that is very important in keeping, that's the glymphatic system that's activated. That's very important in keeping the brain healthy and young. And the team at Cornell that discovered that also posit the theory that nutrients are also taken through the glymphatic system. I don't think they've proven that yet, but that is the hypothesis, which sounds plausible. And that only happens in deep sleep. Spermidine helps with deep sleep. So you could be getting a brain upgrade that way.
Yeah, if she has any gadgets like an Oura Ring or BioStrap, I mean, that you see, I've seen the difference where my deep sleep, and I've played around with Spermidine, where I take it, monitor the deep sleep scores, and then I take it out, and then I see it eventually going down, and then go back on it. Deep sleep goes up. It's anyone who's wants to experiment, be your own biohacker, and use these gadgets and see, for yourself, what are you seeing with your own Spermidine experiment.
What I will say, it's a caveat, is that I think this works in about 70% of the population. It is not consistent with everyone. So there is a segment of the population who take it at night and say it gives them energy. Those people are better off taking it in the morning. But it does still seem to have a positive impact on their sleep at night. But it's just a question of when you actually take it.
Good answer. We have a question from Tanya. Can you unmute?
Hi.
Hi, Tanya.
From Berlin. Hi. I have a couple of questions. My first one, I'm just getting over COVID. But you know what? It was a 2-day thing. It wasn't a biggie.
Well
but
done.
There was a study done on COVID and Spermidine from the university here, Charité. I could only find one study. I took it throughout my Primadine. It didn't stop me from getting COVID, of course, but my feeling is that, and from what I've heard from other people in the space, is that it shortened the infection. It's all anecdotal. I wondered, is there any other information? Do you
there is a study that's happening in Wales at the moment, but as far as I know, the data hasn't been unblinded yet, and it's certainly not been published.
Okay.
So that is not yet, it's not yet available. So we don't know what the conclusions were. What I would say is that anecdotally, people tell us that it feels shorter. I had COVID. I know Natalia, who's also on here, had COVID. Possibly, yeah, that's right. Zora had COVID. I think Magdalena had COVID. Mine was really short as well. I would actually recommend the original wheat germ derived version over the gluten-free version, because the gluten-free version has some iron, and the iron could feed the.
That's my next question. That would be my next question.
Yeah.
I'm anemic. And I wonder, and I also have a condition that many people from the Mediterranean have, is thalassemia beta. So I have very small. And another, I mean, I know that in Italy a study was done 2 years ago in 2020, and when they realized that there was a certain population near Venice that all have the same, genetic
polymorphism.
Exactly. And they had a much milder or no COVID at all. So I wonder if there's, when you mentioned ferritin earlier, my ears cropped up, and I wondered if there was.
Yeah, that actually could make sense. So if you're naturally anemic.
And have thalassemia, which means I have low iron stores anyway.
Yeah. It's interesting how some of these genetic polymorphisms, possibly at some point in our evolutionary past, actually had a protective.
Apparently against malaria.
Right.
Yeah.
And it's the same with migraines. Those who are prone to migraines.
Me.
Okay. Yes. Well, the studies that I've seen on migraines were that it occurs more often in the Northern European population, and that it was a way to help people sense heat. It's too hot. You're going to get heat stroke.
Okay.
And so oftentimes there was a reason why evolution kept those those genetic mutations in the gene pool, because they had a protective effect. Fascinating about the thalassemia and the anemia and the shorter duration of COVID. Yeah. Interesting.
Right. I hope that answered the question. Anyone else have any more questions before we let Leslie go? Just got about a few more minutes, and then will have to leave. So you can.
I just had one more question.
Sure.
Leslie, you mentioned earlier that about optimizing hormones. I'm 54. What do you understand as, I mean, the process of balancing, whatever that means, it's a moving target. When you say optimizing hormones, do you mean of a 25-year-old, or what would be optimal for you personally, if I may ask, or a 50-year-old?
I personally, on thyroid hormones, I would like them to be of a woman of reproductive age.
Okay, interesting, yes.
And I know of a few clinicians that have done this, and that would mean that if your TSH is 2.5 or below, you're okay. But if you go above that, you need some assistance.
Help, yes.
And that is not the case in every country. So in the UK, I think it was 5 for a while. And then I think they've raised it to 10 if you're older. Yeah. So, but I don't want to be like every other older person who doesn't feel optimal, yes. Right? And so I go with this clinician who I saw speaking at the Integrative and Personalized Medicine Congress here in London about 6 weeks ago, who said, actually, her patients do best when their TSH is 2.5 or below. My TSH is below 2.5. I feel great. I can tell you that when I was age 39 and my TSH was above 2.5, I felt horrible and I had no energy to do anything at all. You know, with regard to the other sex hormones, that paper that I'd shown you earlier about, you know, the pharmaceutical targets to slow aging, they actually put estradiol as one of the ways to inhibit altered nutrient sensing and impaired intracellular communication. So they see estrogen as an anti-aging agent. And that is actually, as I said earlier, that explains one of the differences between women outliving men, is that estrogen is quite protective. So I don't think you need to necessarily overdo it, but listen to your body again. Work with your practitioner to find your own Goldilocks zone. I have met people who've not had quite enough, and I've met people who've had too much. Neither is good. And the only person who is really going to know is you. If you wake up in the morning and you stretch your arms and say, my God, I feel great, life is good, then you're going to be in the Goldilocks zone and you'll know it's right.
Yeah. All right. Thank you.
Sure.
Well, we're going to have to wrap it up. I need to let Leslie go now. But before we leave, I would like to encourage people to go find more about her and her work on Instagram. She's called Leslie's New Prime. She's got a YouTube video I'll have a link to, and go check out Spermidine at oxfordhealthspan.com, or just go spermidine.com. There is a discount that she's given us. Just use the code ZORA. And Leslie, are there any last words or anything else you'd like to direct people to before I let you go?
No, I just want people to remember that if you've got premature aging right now, there's something you can do about it. And that is improve your autophagy, among other things, right? But improve your autophagy, the functioning of that, and you can impact all the hallmarks of aging and slow down the rate at which you are getting older.
I love it. Oh, wonderful. Well, thank you so much. I really appreciate your time, your knowledge. I hope to have you back. And welcome everybody. You know, you're welcome to check out everything and where are the places I told you to. Thank you so much for joining us. Have a good day, good night, good morning, wherever you are. And we'll see you next time.